Yeah. So everything that we're all saying is now being heard. And all the stuff I do on the board will go online.
Slackers.
And there'll be a YouTube video. Okay? So if you go to the class website tonight, hopefully if this all works, there'll be a YouTube video of class. So people that weren't here today, hopefully will go to the class website and say, hey, what's this? There's a video. All the video shows is the board and the voice. It doesn't like show me or you at all. Yeah, it's written up there. I gotta graph this. Yeah.
You find the axis.
How do I find the AOS?
The negative b over 2a.
Keep going.
So it would be negative 6 over 2 times negative 3, which is negative 1. Or I mean 1.
Yeah, so there's like half of you, and yet still talking I can hear. Shh. Negative 6 over negative 6 is 1. What do I do with that 1?
Here we make a table.
Okay.
And you're going to put the 1 in the middle for the x.
Okay.
And you're going to put like 0, a negative 1, or a negative 2. And then a 2 over 3.
I didn't mean to go quite that high, but yeah, that'll work.
You're going to plug the x into the equation, and you're going to find the y.
What does f of 1 get me? One squared is 1. 1 squared is 1. 1 times negative 3 is negative 3. Plus 6 is 3. Minus 4 is negative 1. So it's the point 1, negative 1. And now I can graph that. At the point 1, negative 1. Yeah, right here. Okay, now what? Anybody? Well, I can do a little better than that. Yeah, come on.
Can't you find the, by using the A?
Yeah, the A value is negative 3. So from the vertex, I can go down 3, right 1, and down 3, left 1. And you'll note this point, 0, negative 4, is the y-intercept. We knew the C value was the y-intercept, 0, negative 4. So we have that point and that point. Now, if I wanted to find one more point, I could. One more point's not going to fit on my graph very well. Like if I plug in a 3, I plug a 3 in for x and do f of 3. F of 3 would give me 9, negative 27, plus 18 is negative 9, minus 4 is negative 13. I can't really fit that on my graph, so I'm just going to graph it the way that it is. And we have graphed that equation there. Is there a question about that at all? And on your homework last night, you had things that were like this. Well, they would take the equation and set it equal to negative 2. How would you do that? Same two people? And that?
Oh, whenever it crosses the negative 2 on the x
on the
axis,
y.
On the y. That's where the circle.
Yeah.
That's where it is, and that's the answer.
Yeah, so it's going to be like x equals like 0.2 or 0.3. And x is about equal to like 1.6, 1.8. I'll make it 1.8 so it's symmetric. The graph is symmetric. And how about that? Yeah, no solution. No solution. Because the graph never crosses 6. It's way up there. Question about that at all? Okay, I'll check out your homework tomorrow. I'm not going to check it out today. Today we're going to talk about factoring. You probably haven't factored for a couple of years. Factoring is incredibly important in this class. You're going to factor so very much in math. From here on, every math class you take after this one involves copious amounts of factoring. So we're going to learn to enjoy it. We're going to get good at it. One type of factoring is when you pull out the greatest common factor, which we abbreviate as the GCF. The greatest common factor is the biggest thing that every term in an expression has in common. So, for example, each of these three terms can be divided by 2. Each of these three terms has an x in it. So I can pull out a 2x. However, since the first term is negative, I'm going to pull out a negative 2x. If your leading coefficient is negative, pull out a negative. You put nothing away, right?
Yeah, I haven't turned on anymore.
Well, it probably wouldn't turn on if you weren't playing with it.
It's turned on.
Well, you wouldn't know if it was in your pocket, right?
Sorry. Turn it off.
Okay, awesome. It's not going to be an issue anymore?
No, I'm trying to turn it off.
Yeah, we'll keep talking about this for a while until it's taken care of. Tyler Shackelford, you got it?
Yeah,
Mm-hmm.
that was good.
I factor out a negative 2x. So now every term is being divided by negative 2x. Negative 4x to the 5th divided by negative 2x becomes 2x to the 4th. Positive 6x squared divided by negative 2x becomes negative 3x. Negative 2x divided by negative 2x becomes positive 1. That is my factored form. The idea is if I was to multiply this expression with the negative 2x and this and this and this, if I were to distribute the negative 2x, I would get what I started with, negative 4x to the 5th plus 6x squared minus 2x. What's the GCF in the second one?
2, 4.
Can 4 go into 18?
Yes. No, it's 2.
Can 6 go into 8?
I thought it was 18.
It's not 2. It's not 2xy. 2y. There's no x in this term over here, so I can't pull an x out of this. They all have a 2 and a y, so I'm going to divide everything by 2y. That gives me 9x minus 6xy plus 4y squared, and factor. Question about that? But you should always pull a GCF out first, whenever you can. Factor a GCF first. Difference of squares is like the easiest, quickest, most useful one to look for. It is so nice. If this number is a perfect square, if that term is a perfect square, and this term is a perfect square, and there's a subtraction between them, it only works with subtraction, not addition. If there's a subtraction between them, then it factors into the square roots of them both, 1 plus 1 minus. So the square root of x squared is x, the square root of 16 is 4, x minus 4, x plus 4. Every difference of squares will be that simple. Take square roots, make 2 factors out. What's the difference of squares for the one on the right? Hey, Ray?
Would it be 4x minus 7 and 4x plus 7?
There it is. Anybody have an issue with that? Any question? Okay, what we're going to spend the rest of our class on is talking about factoring a quadratic trinomial. You've hopefully seen this before. I call it factoring into bubbles, where we're going to have 2 things like this. And I want to have something that when I FOIL gets me this. I want to FOIL into x squared plus 7x equals 6, or plus 6, x squared plus 7x plus 6. I know that those are both going to be x's, because x times x is x squared. Now for my other slots out here, I need two numbers that multiply to 6 and add to 7. What two numbers multiply to 6 and add to 7? All right?
X plus 6 or plus 1.
6 and 1. So factors are 6 and 1. If I were to FOIL this expression, I would have x squared plus 1x plus 6x plus 6. And 1x plus 6x is 7x. Yeah, that just happened. So this is my check. The answer is the actual factored part, and you can check by FOILing it if you want to. What are two numbers that multiply to negative 14 and add up to negative 5?
Negative 7 and 2.
Negative 7 positive. Is that ringing a bell? Just coming back to you? Good. It gets tougher. Right now the a value is 1. The term in front of the leading coefficient, the coefficient there is a 1. As a increases to something like 2, it gets a little bit tougher. Because now I know that this spot's going to have a 2x, and this spot's going to have a single x, because 2x times x is 2x squared. Which means whatever number I plug into this slot right here is actually going to get doubled, because when I do FOILing, this goes here and here, so this spot over here is going to get doubled, and I have to account for that when I do my factors. So the only factors of 3 are 3 and 1. So I'm going to put a 3 here and a 1 here, and they're both going to be negative. Negative 1 times negative 3 is still positive 3. But this term gets doubled, so I have negative 6x minus 1x to get the negative 7x that I needed up here. That's my factor. That makes sense? I'm assuming no, because last time I asked those questions, you all said yes right away. Let me FOIL this and show you what happens. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. But these two numbers combine to give me 2x squared minus 7x plus 3. But the important thing to recognize is this line right here caused this number to double.
So basically, we're just literally simplifying.
You can think of it that way. It's not literally what we're doing, but you can think of it that way, yeah.
So, but I can think in my own head.
Yep. Will you try the one on the right on your own? Take a second, try and factor the one on the right. I'll pause this recording, and then hopefully when I start it, it'll keep recording. All right, Will, go for it.
Pretty wrong, but you know what? I gave it a shot. 2x plus 1.
Thanks.
And x minus 6.
Okay, Will, FOIL this for me. Yes, it is. Yes, it is. Very bad sign.
Is that supposed to be a 7 instead of a 1?
Well, FOIL this for me, okay?
Okay. 2x squared minus 8 or 12x. Yeah, we're just gonna stop there.
Yeah, it's not working, right? It's not working. This number gets doubled. This number right here gets doubled. I know you'd think it'd be 6 and 1, because 6 and 1 add to 7. Oh, this is very annoying. Thank you. You'd think it'd be 6 and 1, because 6 and 1 add to 7. But this spot gets doubled, so it's not 6 and 1. You have to think about that doubling. Parker, you seem to have all the answers today.
I'm pretty sure it's right, so.
Uh-huh. Go for it.
So first parentheses, 2x plus 3. Second parentheses, 2 is x plus 2.
Yeah, it wasn't 2x plus 2. That's ridiculous. It's just x plus 2.
That's what I actually originally had over here.
Yeah, thanks, Will. 2 times 2 is 4. 3 times 1 is 3. So 4x plus 3x gets us our 7x in the middle. Okay. One more. Try that one on the right over there. Pause it again. You know how to do it? So you could just grab your phone and text somebody? Was that? Yeah. If you have my number, you can do that.
What we're talking about? Yeah, that's awesome.
Anybody factor this?
Raymond
Rating and Trig,
Sure. Take a shot at it.
Well, I'm not completely sure what the other variables going to be, but would you split up the x, or the 6x to a 3x and 1 and then 2x and 9?
Or it could be this, or it could be this. Next. Right, there's 2 possibilities, which makes this much more difficult. What makes it even more difficult? The fact that you should have factored out a 2. Pull out a GCF first, okay? If you factor out a GCF first, this gets so much easier. Literally 4 times easier. Like I can calculate how much easier it is. It's 4 times easier. If I pulled out a 4 here, I would have said 16 times easier. Then I try and factor this. The 2 is just going to sit there. The 2 just hangs out. And I'm going to have 3x and x. 5 and 1. Positive, negative. And that's how it factors. That guess and check method, which is how I usually go about this, where I just kind of start filling in little bits that I know and go from there. 3x, x, 5, 1, positive, negative, is a great way to factor. And if you get a lot of practice at guess and check, and if you really start to look for patterns and look for things that can and can't work, you can get really good and very quick at factoring by guess and check. And that's the way to do it. And that's the best way to factor, in my opinion. But I'm going to show you a method now called factoring by grouping that'll work every time. It just takes a little bit longer. There we go. These are the steps for factoring by grouping. And I'll give you a second to write them down, or I'll give Tyler a second to turn off his light and then take a picture with his phone. If you want to take a picture of this with your phone, feel free to.
I'm not lying that it actually just came out.
I don't care, though. I'm not lying about that either. Okay, so either write this down or grab your phone and take a picture of it. I'm going to make a poster and put it on the wall eventually. This method, this factoring by grouping method, works every single time. It takes longer, it's got some steps to follow, but the nice thing is it will always work and always spit out the right answer.
Papa.
Okay, I'm gonna run through these steps. Why is step 0 called step 0 and not step 1?
Not always gonna happen.
Yeah, it's not always going to happen. It's not necessarily going to happen. And it's not really part of factoring by grouping. It's just part of how you factor in general. You should always look to pull out a GCF first. So in this case, if I pull out a GCF, I'm pulling out a 2. Okay, sorry children. We had some technical difficulties. We're going to factor in new ones. Factor by grouping. First step, whenever you can, step 0, because it's actually like a pre-step. It's so important. Factor out a GCF. I can pull a 2 out of all of these. Step 1 of factoring by grouping is to multiply A and C. Well, this is my A value. This is my C value. 3 times 4 is 12. The next step is to find two numbers that multiply to 12 and add to 7. Well, it's 3 and 4. I've already got those. So I'm going to take these two numbers here and replace the 7x with them. So I have 2 and then in a bracket 3x squared plus 3x plus 4x plus 4. So the 7x got split up into 3x and 4x. Everything else stays the same. Now, we're on step 4. I'm going to cut this in half right there. Right between the 3x and the positive 4x. The sign is very important, so I'm going to keep the sign with the 4x. My 2 still just sits out there. These two numbers can both be, or those two terms, I guess, can both be divided by 3x. So I'm going to factor a 3x out of both of those, and I'm left with x plus 1. These can both be divided by 4. So I'm going to pull out a positive 4. I keep the sign there, plus 4, and I have another x plus 1. Well, since these two bubbles are the same, and they'll always be the same if you've done this correctly, that's one of my factors. It's like they both combine into an x plus 1. Since these are my leftovers, the stuff in front of the parentheses also becomes a factor. That goes there, that goes there. And the 2 in front just sits there. So it's 2 times 3x plus 4 times x plus 1. Again, that is not the fastest way to factor. In fact, that problem is not hard to do by guess and check or by any of your other methods you might have learned in the past. But this grouping method works every single time, and that's what's nice about it. If something can't be factored, you would see that at this step here. If there weren't two numbers that could multiply to AC and add to B, then it couldn't be done. Is there a question about that at all? Sweet. Well, then the last little wrinkle to throw in is solving. So far, all we've been doing is factoring. And we solved by graphing on your last homework assignment, and to warm up today, we solved by graphing. Today, we're going to solve by factoring. Solving by factoring just adds a simple little step here and there. I'm going to factor the right side of this equation into minus 6 and minus 2. Negative 6 and negative 2 multiply to 12. Negative 6 and negative 2 add to negative 8. Well, now I want to know what can I plug in for x to make this first bubble right here equal 0. Because if that equals 0, 0 times anything else is going to be 0, so it'll solve my problem. Well, x could be 6, or x could be 2. If I plug a 2 in for x, 0 times whatever is 0. Those are my two solutions. Question there? this method, this factoring method, only works if you're equal to 0. So I have to, if I'm not equal to 0, I have to get equal to 0. So I have this. And I'm going to factor that. Well, you can try the grouping method if you'd like. I'm just going to try and guess and check and see if I can make it work. Two numbers that multiply to 6 and combine to 5 will... Those are all the options that multiply to positive 6. Because one of these numbers, whatever number goes over here, is going to get combined with this 2, this is impossible. I know that 3 and 2 add to 5, but whatever number we put right here, it's doubled, so it's not going to work. This one can't factor, so it has no real solutions. Can y'all follow that? Any question there? There's nothing I could plug in for x that would make 2x squared plus 5x plus 9 equal 3. Nothing real anyways. Can somebody factor the right one, the far right one?
That was definitely a genuinely really fun.
No one was thinking that before, but now it's going to be on YouTube, so... Will is claiming he did not fart when that fart sound was made back in the corner.
It was really chair, I swear to God.
I know it was. How does this factor?
-2 and 3.
Negative 2 and 3 do not multiply to positive 3.
Right, yeah.
I want two numbers that multiply to 3.
It's not possible.
It is possible because one of these numbers gets doubled, Will. You have to remember that. This number here is going to get doubled because of this 2. Yeah?
Negative 1 and positive 3.
So I'm going to have a positive 3 here and a negative 1 here. That's going to give me 6x minus 1 to get 5x. I want negative 5x, not positive 5x. So it's plus 1 minus 3. That's how it factors. Well, if 0 equals 2x plus 1 and 0 equals x minus 3, I know that one of the solutions is x equals 3. The other solution is negative 1/2. Here's so you can get that. This fraction one over here on the left. What I do is I just take the opposite of this divided by this. And negative 1 divided by 2. That will always be your answer. The opposite of this divided by this. But what you're really asking is 2x plus 1 needs to equal 0. I want this bubble to come out to 0. So I set 2x plus 1 equal to 0 and then solve for x. That's one of my solutions. My solutions are x equals negative 1/2 and x equals 3. Question about any of that?
Uses.
I believe that takes care of our day today. Oh, one more. Do that one. Will, you done already? You're all done?
Huh?
You all done with this problem? I'm sorry, pack it up.
Nice.
Now what do I do?
Okay, what do you do after this? Did you find a common factor?
Which is?
Let's see. 2.
Nice.
So you get 3x squared plus 10x plus 3 equals 0.
Mm-hmm.
And then...
I'm going to try it by guess and check. If you want to do it by grouping, you can. I want to put something here and something here. The only options are 3 and 1, positive and positive. So my solutions are going to be -3 and -1/3. This 2 has nothing to do with the solutions. It's part of the factoring process, but has no bearing on what solves the equation. The equations are just -1/3 and -3. I have today's homework on the board and block day's homework. So homework 37 is the one that's going to be due on Monday when we get back. Tomorrow I'm going to check off 2 assignments. I'll check off 35 and 36 on block day. Any questions? Great. Well, let's hope this whole thing worked.